Quite often we need to execute some code when an asynchronous operation completes. For example, we may want to display the result or store it in a database. Let me show you how to do that. First, let's create a completable future object. Here we call the supply async method and pass a lambda that returns 1. Now this returns a completable future object. So let's store it over here. Now here we have a method called then run. This is one of those methods that is provided by the completion stage interface. So if you type completion stage x and then type x dot, here we can see all the methods declared in this completion stage interface. Earlier I told you that this interface represents a stage or a step in an asynchronous operation. So here we have a bunch of methods for modeling complex asynchronous operations. A lot of these methods start with then. That means when this task is finished, then do something else. So here we're going to call future.thenRun. That means we're going to run some code once this task is finished. Now, here we need to pass a runnable object. So we pass a lambda and print a message like done. Let's run our program. Here's our message. We also have then run async. This method is like the run async method that you saw earlier. It's basically saying run or execute this task in an asynchronous fashion. So the task that we pass here, this runnable object, is going to be submitted to the underlying executor and executed asynchronously. Let me show you. So I'm going to change this lambda. Let's add a code block. Here we print our done message. But before that, let's print the name of the current thread. So thread.currentThread.getName. Now let's run our program. You can see that this task was executed on this thread, forkjoinpool.commonPool worker 3. In contrast, if we call then run, this task is executed on our main thread. So that is the difference between then run and then run async. Now we also have another pair of methods called then accept. This is useful if you want to get the result of this completable future. Let me show you. So delete. Look at the signature of this method. Here we should pass a consumer object. We talked about consumers earlier in the course. So this consumer interface has a single abstract method called accept. It takes an object and doesn't return a value. So here we can pass a lambda like this, result. And in the body of this lambda, we're going to print the current thread. So thread.currentThread.getName. And then we're going to print the result. Let's see what happens. So this task was executed on the main thread, and here's the result of this task. Now, similarly, we have then accept async, and this will submit this task to be executed asynchronously. Take a look. Now this task was executed on this thread, but we don't see the result. This happened because our main thread finished earlier than this other thread. So if we put a delay in our main thread, we can see the result. Let's put this in sleep for, let's say, 2 seconds. And run the program again. There you go. So here's our thread and here's the result. So this is how we can execute some code upon completion of an asynchronous task.